Hi there. I'll be talking to you about Swarm tonight, Docker Swarm. My name is Everett Toews. I'm presenting to you right here and right now. I'm a developer advocate here at Rackspace, working on Karina, containers as a service product from Rackspace. And I do, a lot of client tooling development for Karina, do deep dive tutorials, and then I do advocacy, which is the guy standing before you right now doing that. Okay, so what are we trying to get out of this particular presentation? Getting started with Swarm is super easy. So we're gonna get past that pretty quick, and we're gonna get into using it a little more effectively. Don't worry about this. It's just so you can jump into the presentation when you're viewing it online. You can jump into any point that you like. Okay, so Swarm. What is Swarm? If you're not familiar with it yet, conceptually, it's really very simple. Prior to Swarm, or if you weren't using another Docker orchestration tool, you might have a collection of Docker nodes out in a cloud somewhere. Whether they're running on VMs or bare metal or what have you, within your own data center or wherever they're running. And you're treating each one of these nodes as like a separate entity. And you have to worry about, okay, my containers are going onto this node, this container is going onto that node, and you're putting all these containers onto the different various nodes, and you're all planning it very carefully. So really, Docker Swarm is Docker's answer to clustering. So they'll take a collection of Docker nodes or Docker hosts or, Docker servers, whatever you want to call them, and treat it as a single node, treat it as a single host for your Dockering, right? Now you have one endpoint that you can talk to, and it's going to schedule your container to one of those nodes in that cluster. So what are some of the benefits of actually working with Swarm? That's really strung out here. Okay, so Swarm just uses the native Docker API. So kind of the differentiator, the difference is there is no difference. It's just Docker. So everything that you've already learned, you can apply immediately to Swarm. It uses the same Docker command line interface. A lot of the ecosystem tooling, practically all of the ecosystem tooling, will still work with Swarm. If it worked with just a single Docker node, a single Docker host, it'll work with Swarm. In most cases, you might need to tweak it in order to take advantage of Swarm's clustering capabilities. And kind of the primary thing that Swarm gets you is being able to schedule your containers across that cluster. And there are various strategies for doing this. Swarm itself comes with two schedulers, spread, which is just kind of like round robin, putting your containers on the different nodes in a cluster, or packing them into, as tightly as you can onto one node and filling it up before, packing them on to the next node and going like that. But you can also plug in different schedulers for Swarm, and I believe you can even use the Mesos scheduler for Swarm. That's something I haven't played around with. You can also use something called constraints and filters when it comes to actually scheduling or getting your containers running out on a cluster. Constraints are for specifying, okay, I need this container to run on a node with these characteristics. And you usually define those characteristics with simple labels. You label a node with SSD. And you say, when you go to run your container, oh, I need to run on a node that has an SSD. So Swarm will schedule it to that particular node. Filters, shoot.
As the scheduler, right?
Say again?
That feature only works if it acts as a scheduler. Like using Mesh as a scheduler, would you still be able to set the constraints?
So the question was, does that work if you're using the Swarm scheduler? Does it work with other schedulers? The answer is I'm not 100% sure because I haven't used one of the plugin schedulers. I would hope that you'd be able to do something similar, but I don't know for certain. And then filters are primarily for scheduling containers together. If you need two containers running close to each other or on the same node for sure, you can use affinities to say, oh, schedule these things together such that they run on the same node. And then this one's an experimental feature that I haven't tried out. Rescheduling containers when a node fails. So if a node goes down, everything that was running on it really should start running somewhere else, right? And you get that failover. Haven't tried that out yet. It's experimental right now in Swarm 1.1, and I think it's moving out of experimental in Swarm 1.2. We have a question here?
Yeah, real quick.
Sure.
Before you get too far past the affinity thing, is there such a thing as like an anti-affinity?
There is? Okay, yeah.
Okay, I'm like going through the documentation trying to find it, but I figured you would know.
Cool, yeah. No, I haven't had to use an anti-affinity yet. I have used affinities, but not an anti-affinity yet. And then we're still kind of sort of talking about pets versus cattle in a sense. Like if you've got a handful, a collection of Docker nodes, and you're kind of very picky and choosy about where containers get scheduled, in a sense, you're still kind of treating them like pets. You're putting them into different pens and saying, oh, you're going to be in this pen and you're going to be in that pen, and you don't put the chicken with the fox and yada, yada, yada. So when it comes to swarm clustering, like you're really treating these things like cattle now. Like you don't know where they're going or what they're doing. It's just, you got to make sure you're architected so that these things can land anywhere and still be able to talk to anything else that they need to talk to. Okay, so where does Karina fit into the picture? Karina is this new containers as a service product by Rackspace. Really, it is kind of this simple conceptually. Push button, receive swarm. Like this is what basically all you need to know about it. I can dive into it a little bit more if people like, but conceptually, this is it. So let's go ahead and push a button and receive a swarm. These are links to a couple tutorials. You can get started with the GUI or our command line interface. The GUI is great if you just want to dive into it right away. With the command line, you can go and install the command line interface very easily. If you're on a Mac, it's with Brew, Windows, Chocolatey, Linux. Just download the binary.
So is this Karina to Docker, what Fuel is to OpenStack, what Bosch is to Cloud Foundry? It's kind of same.
It's so
Everett,
yeah.
sorry, we have two choices here. Either I run through the aisles and hand everyone this microphone,
Oh, sure.
you repeat the
I
questions.
repeat the question. Yeah, my preference would be to have people ask their own questions on the mic. So if people want to ask a question, they can raise their hand. So let's go ahead and have you ask your question there.
Yeah, I was just asking if Karina is to Docker or Swarm, what Fuel is to OpenStack, at least the one of their implementation, I forgot the name now, or Bosch is to the Cloud Foundry. Sort of sets up the infrastructure where then these things.
Yeah, that's fair to say. The most accurate analogy there is to say that the Karina CLI is to Swarm as Docker machine is to a Docker host. So and you'll see that we actually mimic the Docker machine CLI interface pretty closely. So I'm going to focus on the CLI aspect of it here. So, after you've downloaded it and everything and you've got it on your machine, you can go ahead and we're going to create a 3-node cluster. And that wait flag is there just so that, the CLI waits until the cluster is actually created before returning. Just for convenience, it's not really necessary. So we've got our 3-node cluster up and running, and we're going to we created it. Now we're going to get the environment for that cluster into our terminal session. So this tells you how to do that. And this mimics the Docker machine interface very closely. And you can either source this Docker end file, or you can do an eval on this command here. So let's do that. And there's no output. But now if we do an env and grep for our Docker environment variables, it will have filled in everything that we need for our Docker CLI or other Docker tooling to connect to our Swarm. So of course we've got our endpoint, we've got our TLS and cert path. for authenticating and encrypting all our communication. And Docker version, this is something that we throw in that one of our other tools, Docker Version Manager, keys off of. So if you're working with multiple different versions of Docker, you have this Docker Version Manager command line thing that lets you easily switch between the different versions.
Before you go too far, I understand you started the 3 nodes, got that. Where did you get the, are you on your remote machine connecting in to set your environmental variables and your certificates?
So this is, okay, yeah, good point. So the context here is my laptop.
Okay, so you already built your certs on your laptop.
No. So it was, those were created for me by Karina. And the command line interface actually downloaded that cert pack. Yeah, and if you do it from the GUI, it's actually another button push in order to download that cert pack. It's a zip file with all of the stuff that's in this directory here. This is just one file in that directory, and we'll actually see a little bit more about that a little later on.
I know why you did this, right? You just want to see me run around.
Just want to double check on making sure I'm parsing this properly.
bet.
This is a client that runs a terminal on your laptop that's driving something in the cloud.
Correct.
Okay.
Yeah. And that's like it's a few slides away. Yeah.
This is a local Docker, though, right? As that Karina's talking to, because you haven't introduced any cloud configuration.
Well, here's the cloud configuration right here. Yeah, totally fair question. So here's my cloudy endpoint. This is good though. I'm realizing that maybe I should have put another slide before this slide.
Why do you want to go?
Yeah. Sure, yeah. The intention was like, okay, we're gonna dive right in and we're gonna get something done. And then I'll show you the conceptual stuff. But I think I'm gonna rework it so that there's that conceptual introduction first, and then I'll show this. That's excellent, thank you. Okay, so yeah, and then yeah, of course, help, and you can find out all the things you can do with the Karina CLI. So yeah, and then here's let's dive right in and actually do something with our swarm. So this is kind of the most non-trivial thing you can do is create two containers and connect them. So we're gonna do kind of the standard WordPress example, and we start by creating a network in our swarm. We create a network in our cluster, and we're gonna get into the details of that a little bit later. Get an ID back, and then we go ahead and we do a Docker run. That's because it's been configured with those environment variables we saw earlier. This just works, and we give it a name, attach it to the network, and just give it a random password. Create that as usual, and then we go ahead and we create our WordPress container. Again, a name, attach it to the network. This time we're publishing port 80, so we're exposing that port on wherever this container landed on one of the nodes in our cluster. We're publishing port 80, and this is an interesting bit here. We're passing in the name of the container that we ran before. So we're just saying, okay, here's where you find my MySQL host, right? My MySQL instance. It's running in a thing called MySQL, conveniently, and we get our ID back. So now you can start that blog that you've always wanted to, right? And start blogging in Esperanto like you've always wanted to. So let's take a look at the couple of containers that we just started. Your basic PS output. Let's see if I can scroll over without destroying anything. So you can see that the container. The WordPress container was started. It has this public IP address with this exposed port 80 there. And I have a feeling I know what the next question is.
Compose?
Oh, compose. Okay, actually, that's a good one. That was not
'Cause you
what I
ran
expected.
it.
Yeah, so
Couldn't have used Compose instead?
I could have used Compose. Yep, indeed.
Assuming you have also a load balancer, can you scale your Docker containers already here?
So I'm going to get into that towards the end of the presentation when I talk a bit about service discovery. Oh, we got.
Sorry, just one question on the, when you're doing Docker run commands, how does it know to send that to the Swarm cluster instead of like maybe running just a Docker run on your local host? Yeah.
Yeah, that goes back to, the environment variables that we set before here. It all keys off this endpoint here.
That endpoint. Okay, got it. I missed that. Thanks.
Yeah, no problem. So let's go back. Got this, got that. Okay, so this is a Mac thing. If you're not on Mac, I'm sure you can kind of work out how to paste that into your browser. And the Docker port command basically spits back the IP address and port where a container of this name is running. So this on a Mac, this will open up your browser and take you right to your WordPress instance. And then, because I very much intend that you can follow along with this presentation at your leisure. You always want to clean up your stuff, clean up your containers behind you. So we go ahead and we remove those. So now here's everything that we were talking about before.
And you're probably about to just answer this question.
Sure.
But is that HTTP getting routed through the Swarm master, or is it on
Straight to the node.
straight to the node?
Straight to the node, yeah. So each node gets its own public IPv4 address. Okay, so, and that's that was a design decision for convenience. Here's how Karina works, in a sense, kind of a very high level, abstract view of it, not super detailed, but I think enough detail to get the point across. So when we were using the Karina CLI here, we were talking directly to the Karina cloud, and that was the thing that created our Docker Swarm cluster for us. And in this example, I just have 2 nodes, Yeah, we actually created 3 nodes before, but because of screen size, basically, I've just am displaying 2 nodes here. So once you've done that, Karina kind of fades into the background, and now you're just working with Docker Swarm. So now you've got your Docker CLI configured, and it's talking to this Swarm manager. You'll have what's effectively your management node. And then you'll have Swarm agents running on all of the other nodes. And it has a data volume container with some certs and stuff and configuration information for the Swarm. Now, this console here is used to help us create the overlay networks in Swarm. It's really an implementation detail and isn't available for you, the user, to actually access and use. It's, only... Yeah, it's a Karina implementation detail, but ultimately you can actually see it, and I'll show that in the next slide. And it too has a data volume container. And then finally, of course, you've got all your user containers, everything, all your applications and service that you yourself are running in your clusters. Of course, all being managed by a Docker engine on each single node.
Everett, quick question.
Sure.
With respect to Karina and the way that masters are set up, does each user of Karina, are they sharing masters?
No, each cluster has its own master.
Okay.
And it's actually not in a high availability setup.
Okay. That was my next question, was to the extent that it was highly available.
It's not in a highly available setup yet, no. Did I mention Karina's in beta? And it's free too. Yeah, that's right.
Actually, we had it set up in an HA configuration, but the masters don't handle that situation very well. There was some lag in, like, when you deleted nodes, that it would take a really long time for the masters to all know about that. And so there was like a split brain happening. So I don't think they're designed to run, like you can fire them up and they appear to be working for the most part, but after a while they get a split brain situation happening. So that's why we removed it.
Yeah. And it's the kind of thing that, it's work is being done on it upstream. We're really very much consumers of Swarm from Docker. Shoot.
Could you, as you go forward, could you try to distinguish for us what's Swarm and what's Karina on top
Yeah,
of Swarm?
so I'm basically going to be talking like very little about Karina for the rest of the presentation. Yeah, except for like this line here and the cloudy bit. That's where Karina comes in. But after that, it's all Swarm. Yep. Yeah, it's all running within your Docker Swarm.
Yeah, so could you give like 10 seconds on like what's the relationship between Karina and Swarm for somebody who has no idea what you're talking about?
Sure. So to sum it up, Karina, it's the push button receive bacon thing, right? So Karina creates Docker Swarm clusters for you. If that clears it up. Right. Yep. Let's use a mic, please.
I assume you plan to provide high availability.
What do you think, Simon? This is Simon J. He's the product manager of Karina.
I was just gonna, as a feedback, maybe to do the before Karina, how hard maybe it is to set up, a regular Swarm cluster if you didn't have it. That will set the tone for us to then see what Karina brings to the table.
Oh, sure. Yeah, like the automated creation and configuration. Yeah. Yep.
Can you only use Karina on Rackspace?
The question is, can you only use Karina on Rackspace? Well, yes. Yeah, effectively, yes. Karina is something that we created. There are all sorts of machinations behind the scenes so that, you just make a single CLI call and it creates this whole thing for you, the whole Docker Swarm cluster for you. Yeah.
Hey, Everett, I was going to say the difference between Karina and doing it yourself is you'd probably have to write like a chef cookbooks and spin up nodes via something like Ansible or maybe a cloud, whatever that heat template is, that sort of thing to spin up nodes. And you'd have to go and jigger with the certs and all that sort of stuff. So getting all that done out the door without doing anything, you just brew, install Karina or what have you. It's pretty awesome.
Yeah, it makes it like super convenient. It's the same as like, are you going to use DynamoDB on AWS, or are you going to deploy Cassandra, your own Cassandra? Are you going to run your whole, create a whole Elk stack and run that on bare metal? Or are you going to use one of the services from, I think Elastic even offers that right now. It's just hosted open source service, which seems to be pretty common these days.
It should probably also be mentioned that Karina currently is bare metal as well. So, worth mentioning.
Yeah, that really is worth mentioning. And okay, so this is interesting. This is actually really good feedback for me. There's a lot more appetite for details of how Karina is built than I was kind of expecting. But yes, so these Swarm clusters, well, actually, I should say the individual Docker nodes are actually really LXC containers. And so you've got, containers running in containers, and that's what gives you the bare metal speeds of actually running these containers. You don't have a hypervisor overhead. And this is all actually quite well documented on the getkarina.com site, how this all kind of fits together at, I think, a reasonable level of detail, pretty much as much detail as we're able to give out, really. Were there any other questions?
I see that you use Consul for service discovery, but you have in the roadmap some kind of load balancer or something like that to interact with Consul.
What was the second half of the question again, please?
If you will introduce some kind of load balancer that interact with Consul.
Yeah, so, right. So No. Short answer, no. But I am going to talk about that right towards the end of the presentation when I talk about service discovery and how that can be done with a swarm. And yes, you can do it with console, but again, you cannot do it with this particular console. This is strictly for Karina's use only and is inaccessible to users.
It's for Karina, not for the services, right?
Correct.
Okay.
Yeah, just an implementation detail.
Thank you.
Thank you. So my only experience with Swarm is a couple of YouTube videos I saw, dude setting up a bunch of Docker machines, and pretty awesome. So the feedback based on him, we need to distinguish how difficult it is to set up a Docker Swarm cluster from scratch and what Karina provides. Now, my thinking was the complementary of Docker Swarm in terms of GUI with Shipyard. What do you have to say about the GUI for Karina and Shipyard?
So I haven't actually used the GUI for Shipyard. We've got a good blog post on our site on getkarina.com that actually shows you how to configure Shipyard to work with Swarm. I haven't had a chance to run through that yet, but it is. Yep. Yeah. So I mean, you can use most any Docker tooling that works with Docker, like Shipyard, on Docker Swarm. And to your point about, how complicated is it to set up a swarm, Docker Machine actually makes it pretty darn easy to set up a swarm. Like, it is super easy to start playing around with it and get your feet wet. Not everyone has Docker Machine. Well, not everyone has Docker Machine. And it's, running on VirtualBox, or you can get it running in clouds and stuff, and they have guides for that and stuff. It also comes back to, is it production ready? The swarm you're building, is it really production ready? Does it have that bare metal speed, et cetera, et cetera, et cetera? Do you really want to manage this thing? And maybe you do, and that's totally great.
In this picture, where does Docker Swarm's console live?
Where does the console live?
Docker Swarms, not your console, not the Karina console, but the console that manages the topology of the swarm.
Are we talking about console, SUL, or CONSOLE?
Well, when you start manually building up a swarm, you usually start by configuring some host which contains console for the metadata of the topology.
Yep, yeah, that's
discovery.
true. Yep.
Where does this live?
It's just a container. It's console running in a container on your cluster, on your swarm.
So okay.
Yep, and it has agents out here.
So the console used for discovery of the swarm itself runs on the swarm.
I mean, yeah, conceivably, sure, you could probably run a whole nother node just for console. There's no real reason to. There's no good reason to. You might as well just have it running on the nodes that you already have. Shoot.
What fraction are you through this presentation? Maybe we should let you finish, and then we ask our questions.
I owe you a beer, good sir. Yeah, maybe we'll keep moving.
I think I can help. I spent 4 hours today with 3 nodes, loading TLS, building all the certificates, transferring all the certificates, making sure the certificates worked. And I went to Karina this afternoon and pushed it, and it took 2 seconds. So that's the difference
Cool.
that I've found so far.
Yeah. Yeah, thank you. Really, that's great to hear. Like, that's it. That's the experience we're trying to deliver, right? And literally in less than a couple minutes, you can go from like not even signed up to deploying containers with the Docker CLI. It's kind of crazy. Okay, so let's move on. There are a handful of constraints when using Swarm from Karina, and kind of the TLDR is you don't have access to the Docker node. Because this is a multi-tenant environment, you can't really access a node because then everybody has access to the node and who knows what's going to happen. Nothing good. So you can't use volume mounts. If you've got the colon here and you're trying to mount something from the node, some path on the node to some path on the container, you're going to get an error. Except for you can actually mount the local Docker socket from that node, because there's a lot of Docker tooling that depends on being able to access the local Docker socket in order to get work done. And I get into that. I get into how you work with volumes and stuff, in the data section later on in this presentation. You can't use privileged or any of the capability stuff, again, because security. We also have additional app armor restrictions running on the nodes, so that you can't bust out of the container and get onto the node and start doing bad things. And all those containers that I showed you before, all the Karina management containers that I showed you before, just try not to delete them, because your cluster will kind of shut down when you do. But it's not the end of the world. There's actually a convenient rebuild command that will recreate those containers, and your containers are still there, and they're just fine. So you can do a Docker info when you're attached to your Swarm and see a lot of information about what's going on. We have the strategy set to spread right now for clusters. That's not configurable at the moment. And of course, you can do all the different filters. There's our 3 nodes that we created. And if you do a Docker PSL, this is a truncated output here. But here's where we see those Karina management containers that I showed in the previous slide. So we see this is the head node, the node number 1. So we see our Swarm management container, the data volume container backing it. And then here's where you see console running and the data volume container behind that. And you'll see these same containers on each and every single node, with the exception that, on the other nodes, it's a Swarm agent. Shoot.
Is the Karina console on Docker Hub, or is that a private registry?
No, it's out on public Docker Hub, yep. And it's very similar to the Glider Labs one that everyone else uses, or most people are still using the one from Jeff. Okay, so effective Swarm slightly cut off for some reason. Cool. In order to get deeper into this stuff, it does take some knowledge and understanding and working with it and figuring your way around stuff. So let's start with images. We had that good discussion right at the beginning with the tips and tricks around images. And here's some of the stuff on Swarm where you have to be aware of, because that trivial example that we used at the start, or the quite not trivial example that we used at the start, sure, that looks great, but it doesn't take long before you start getting into these other issues that you need to figure out alternative methods of doing things. So that hosed it, didn't it? There we go. Let's try that. Okay, so let's go ahead and pull an image and run a container like you would normally. So we're going to go ahead and we're going to do this with just an official image that we're pulling from Docker Hub. And we see that it pulls down to every single node on our cluster, right? So it's all downloaded, it's all good. Now I go ahead and I run it once, that's fine. Run it twice, that's fine. Run it 3 times, that's fine. Because we've got Nginx now running on each one of our nodes. We've got 3 nodes running 3 instances of Nginx. They each get the public port 80 on each of those nodes. If I were to run it again, it wouldn't work because we wouldn't have a port 80 available. Of course, I could always map that port 80 to something else and get it to run, but no one's expecting Nginx to be running on something other than port 80 if you're exposing it publicly. Okay, so that all worked good. We go ahead and we delete our containers. That's exactly what we're expecting and exactly what we want. So now let's build a custom image. And this is kind of a contrived example, but let's say you've got your own requirements for Nginx, which you often do. So we're going to go ahead and we're just going to grab the Docker, the default Docker file for Nginx, and let's say you wanted to modify it or something, what have you. Everyone's got custom images they need to build. So let's go ahead and build one, and we'll tag it and just call it my Nginx. And that goes ahead and gets built out to the swarm. Now let's go ahead and run a container based on that custom image. And we're doing pretty much exactly what we did before. And we're publishing to port 80. And that's fine, it runs. Let's check it out. Yeah, okay, I'm not gonna scroll to the side again, but you'll see that it's running on the public port 80 with the IP address of that node. So now let's go ahead and try running it again, publishing again to port 80. This time we get an error response from the daemon, unable to find a node that satisfies image my Nginx, the custom image that we just built. Who can tell me what they think happened here? Not you, Eric. Sorry, right here.
You only built the image on one machine. The other machines don't.
That's exactly it. So the answer was that the image was only built on one machine, one node, and the others don't have it. And that's exactly the answer. So, that's exactly what's going on here. And when you think about it for a while, and I've thought about it for a while, and we've come up with some workarounds that I'll share in just a sec. But the reason that it doesn't get built out to all the nodes actually kind of makes sense. And this was Jerome from Docker that kind of made me see the light on this one. He said, like, sure, if you've got a swarm with 2 nodes, 3 nodes, 10 nodes, building out to every single node, sure, that's conceivable. But you've got people running clusters with, dozens of nodes, hundreds of nodes. Now building out to all of those nodes just from a Docker build starts to not make so much sense. And there's a lot of ways you can think about getting around this stuff. Like, oh, do you run some sort of BitTorrent client within your cluster and share these images around? That's just not even here right now. So there's no point in thinking about it that much. The solutions that we do have available to us now we've documented pretty well on the Karina site, and I hope this works. I think this works out okay. If I didn't lose my Wi-Fi, here we are. So we've got this tutorial on a handful of different ways that we can get around this problem. You can use a constraint and build, be really pedantic and build it to every single node, and then you can run it on every single node and just do it in a for loop in a bash script. It works. This affinity stuff is for previous versions of Swarm. It worked on that first run because there was actually an implicit affinity being used there. So it knew that the image was on one node, so it went ahead and ran it on that node. And then, of course, the other good options are, using a public registry like Docker Hub or Quay. And then there's this last one here that's really very cool, using a private Docker registry. So you can run Docker registry on the cluster and back it, with some sort of object storage or whatever storage you have. And so this is a tutorial on running a private Docker registry and backing it with Rackspace cloud files. But you could back it with practically any other object store. And this particular tutorial was actually basically owed entirely to the work that Paul CZ here did on getting the private registry working with OpenStack Swift. So I basically took that work and said, oh, hey, this can work with cloud files. So really all credit for that particular tutorial goes to CZ here. Okay, so how do we work with kind of local data? Stuff that you'd want that you need accessible via a file system or database data as well. We'll touch on that. So when Docker released their Docker volume stuff, the volume subcommand basically, I was really excited, oh, we can finally get away from data volume containers. I don't have to deal with that nonsense anymore, and I can just use this stuff really easily. So I start kind of experimenting with it, create one called My Data. I list all my volumes. Okay, so it created a volume called My Data across all my various nodes, and it's prefixed the volume with this name here. Okay, that's fine. So I'll go ahead and I'll write a little bit of data into one of these volumes. Okay, so I reference my volume here and mount this directory, and I write a little bit of data to it. That's fine. That all works well, just as expected. So now I go ahead and, okay, now I want to read that data back. So I read and I get, oh, hello, hello. No such file or directory. Who can tell me what happened here? Well, the volume exists on that host, but that directory and that little bit of data doesn't. So, this makes you think a little bit again. And this one this one's particularly not great. So what can we do about this one? Just keep using data volume containers. Again, this is another guide that we've written on using data volume containers, and they're tried and true, and they work really well. With this particular issue, I took issue with this particular issue. I filed a GitHub issue for Swarm on this one, and there's a number of people who already agree that the model that they have for doing volumes on Swarm by default just doesn't work that well, because you've got this ambiguity of what am I actually referencing when I say I want this particular volume. So there's some work to be done there. And of course, you always want to back up and restore your container data. This is a really good tutorial on doing that. And if you want to use stuff with database, like you're fine running your databases in containers and stuff. Like if that meets your requirements, if that works for you, and you can set up like maybe a highly available system with Galera and MySQL and stuff, and you've got that in your skill set and that works for you, or maybe you're backing up so often that you don't even care if it gets blown away. If that works for you and your requirements, great, do it, go for it. But of course, you might want to connect to something outside of your Swarm cluster, whether it's some cloud database here, cloud database there, somewhere that's kind of designed to handle like lots of data and persist it and be highly available and be very durable as well. So that's, of course, a really great option for your production data. And then, of course, you're going to want a really, really good option for this sort of thing to really get rid of data volume containers or Docker volumes. If you had a distributed file system backing your cluster, that's kind of ideal, so that you'd actually mount in something from that distributed file system. You'd have you'd have your own namespace on that distributed file system, and you can just kind of go hog wild and write stuff there, and that it'll always be there, and it'll always be there when you come back again in the same place every time. We don't have that yet on Karina, but we're moving there. That's something we want to get done. We'll see what happens. There was. Oh no, it's fine. I think we just kind of got carried away on that one particular slide.
I was just going to ask, so the goal of treating that Swarm container as a single logical unit, and so therefore everything you do it as a unit, or do you have the concept of sort of the Kubernetes pods? Or, I'm just trying to understand, the implication of these constraints based on what you're trying to describe. So.
Sure. So I can certainly say there's no concept of like pods in Swarm.
Right.
There's no model for that. But yeah, this is like for the case where you want to share data between containers, or you want data to persist for longer than the container that's actually writing the data or reading the data to be around. You just want a referenceable place where you can come back and get at that data that you wrote before. And we've the pizza's here. So why don't we take 5? Okay. Grab a slice, grab a drink, and we'll start again in 5 minutes, and we'll get through the rest of this.
There you go.
Good. What's Dev 9? Dev 9. What is that? It's my company. We primarily research Seattle. Yeah, great area. But we're looking to try and expand a little bit. Yeah. Been trying to get a better feel for the area. So we got a client in this way. Got 3 to 3 weeks. That's cool. Trying to get a better feel for the area. Yeah, what do you guys do? Custom software development. Yeah. So we do some pipeline, all that sort of stuff, but primarily we're doing primarily backend development. Yeah. Yeah. How does that work out? Like when you get a custom thing, I always think it's something like a product, but I feel like always get like a contract about it. How that works over time, like you deliver something after 6 months. Okay, there it is. Right. What happens next? Yeah, that's why a lot of stuff is not just body. Usually come in and we deal with cultural stuff. You guys jumped on the bandwagon. Yeah. How is that how does that work out as far as operational work that's on like where that's I work on OpenStack stuff and that's a big service. Like services actually operations like just a pain in the ass. in terms of managing the release cycles and everything?
Yeah, the release cycle and deployment planning is just like, okay, well, I have 32 servers going with like, you know, 9 different services. I'm like, okay, I'm making a software update to this one. How does it affect this? Everything get rolled out. You have to roll out everything, every node. Like, there's so many different questions. All that is strong CIC and strong CS.
Because your entire system should be hard to do.
Right, but even like the process of like releasing it all, probably not that much more. Probably like, oh, I want to find the proxy nodes, I know where to find traffic.
One thing that I've seen with Chef is great, heavyweight, and complex stuff. We moved away from that
Well, nice thing is like, Ansible is really easy. Like, oh, I want to deploy brand or something like that. That whole like mindset is so right now. If you tell me in the repository, write your play, you want to deploy something, just use my brand, you know, deploy and build stuff. Crazy. Then we have like calls, which are like more or less static. Oh, well, updated and unupdated. Actually, you know, like
another reason, you know, I think it's less about, I think the common
Hey everybody, why don't we bring it in and keep going? Otherwise, we're going to wind up being here all night. So if you don't mind coming and grabbing a seat, or keep chowing down in the back. So let's move on to networks. So we're going to start by running a simple Redis instance, just a lone Redis instance, and reading and writing some data. Writing and reading some data. So we'll go ahead and, very much like we ran that Nginx instance, we go ahead and we run Redis, and we're going to publish this port 6379. That's the usual Redis port, and we're using the Redis official image. Get our ID back. This is that Docker port command that you use to discover the IP address and port of your service. So we get back, like remember I said, every node comes with a public IPv4 address, and we see that this port has been exposed on that address. So now I go ahead and I use the Redis CLI, and I write a little bit of data to my Redis instance. Okay, and I go ahead and I read it back. So that's great. That's exactly what we were expecting. Ooh, that ain't good. So what's wrong here? This one's a little trickier. Remember the context of what I'm working in here. I'm on my laptop here. It's true there is, define wrong. So this Redis instance is exposed to the horrors of the internet, right? This is running on a public IPv4 address on a well-known public port, and this thing would probably get something horrible done to it in a short amount of time. If you've ever watched, your publicly exposed stuff, they're getting scanned by everything all the time, basically. I'm kind of picking on Redis here a little bit. You can actually lock down Redis a little bit more with a simple password, but by admission of the maintainer of Redis, the original author of Redis, it was never meant to be run in a public context. It's meant to be run in some sort of private network where it isn't exposed to the horrors of the internet. Another example, let's go back to that create WordPress example that I did at the very beginning, except this time, notice I'm not creating a network as the first thing I do. So I go ahead and I create my MySQL container. That's all well and good, that's fine. And then exactly like before, I run my WordPress container and I reference my MySQL container like this, and that runs. But let's take a look at the logs. What happens here? So, we die. It can't find this thing called MySQL. It has no idea what I'm referencing when I say MySQL with this environment variable here. So the solution here is to always use an overlay network. I can't recommend these things highly enough. They do a lot of good things for you. Like for example, they provide DNS resolution for the MySQL name. So it's kind of like it's a minimal service discovery, right? DNS is basically service discovery. I'm using a name, I'm getting an address back, not a port, but I already know the port because it's the well-known MySQL port. So just use an overlay network whenever you don't want to expose something to the horribleness of the internet and everything going on there. And you want to be very, very careful about what it is you expose. And then this second link is just for some kind of internal Rackspace network stuff. And at the top of that particular tutorial, it says, forget this stuff, go ahead and just use an overlay network. Question?
Do you have access to Rat Connect?
No. That was easy. Okay, so talking a bit about security. So I am not a security professional, but I do at least want to attempt to address it a little bit and talk about it a little bit and let you know what options you have for security on Swarm or really any kind of Docker environment in some cases. So let's go back to our environment and our Docker variables. So TLS is good stuff. Here's all of our certs and keys and everything live at this path. For the authentication and encryption of all the communication with your nodes, with the Swarm, I should say. And at that path, there's actually a README file that gets downloaded when you download that cert bundle. And that actually explains what some of the files in that directory actually are. So it's all the certificates, all the keys, everything you basically kind of need to do public key infrastructure, PKI. So, and that's just like the default Swarm thing to do. Some kind of general solutions around, without illustrating the problems, just kind of jumping into some of the solutions that we have. So again, just use overlay networks in a lot of cases and don't expose your stuff to the internet. That buys you a lot of security. Not necessarily in depth, but at least you're not fully open and you've decreased your attack surface significantly when you're using an overlay network. This is an interesting one, patching security vulnerabilities with Watchtower. So, if you've got, and this goes to the point that Karthik was talking about earlier, you might actually have, or maybe it was Lee, you might actually have containers that are really kind of long-lived. You might have people who create a container, a WordPress container or something, and just leave it around forever. You don't actually have this people who are doing continuous deployment and constantly rolling their containers and getting them updated from the base images and constantly getting those new patches. That's some people just aren't going to do that because they're just not going to do that. So you can use this utility called Watchtower that runs in a container, and it actually watches your running containers and looks for newer versions of the base image and will roll your containers so it picks up those newer base images that have those security patches. So if that's something that works for your containers and your system and environment, that might be a good option for basically doing automatic upgrades, automatic security upgrades. Maybe it works for your environment, maybe it doesn't. Maybe you need something more complicated. I don't know. So there's also, if you want to start using Nginx and Let's Encrypt, to get to do TLS for Nginx, this is an excellent tutorial, and will get you an A or A+ rating from SSL Labs for your Nginx deployment. Really great stuff. We've got a PKI, a public key infrastructure tutorial in the works right now. Like we've got, I'm referencing, at this point, I'm referencing pull requests and issues. So this is fresh, right? This is fresh information. Doesn't get much fresher. So this should be released in the next week or two for doing full PKI within a Swarm cluster. And then we're also considering enabling a security sidecar for the swarms created by Karina. So this would be running some of the stuff from CoreOS that watches your containers again for vulnerabilities, for images that haven't been updated, images that aren't fully patched, and also running the Docker security bench on some of the stuff. So this is like, you guys can, because Karina's in beta, you guys can literally influence the product direction by replying on issues like this. Like if this is something that would be of value to you and you comment on it here, then that lets us know that we should prioritize development of these sorts of features. Service discovery. So this already came up a couple times. So I know this is, and it's usually a pretty hot topic, and I'm learning a lot about it myself recently. So there's a couple, kind of prominent stacks when it comes to service discovery. There's the etcd stack, which is your distributed key value store, and then you use something called Registrator that actually like watches the Docker Swarm event stream and writes stuff into your etcd. And I'm purposefully not showing you diagrams and getting too deep into it. And then you use like confd for writing configuration for your load balancer and reloading your load balancer. And then you've got your load balancer. So that's a pretty common stack. Another common stack is the console stack, where you swap out console for the distributed KV store and use something called console template for the config writer and reloader. This is a pretty common stack as well. I see this around a fair bit too. For those two stacks, you start considering, okay, what would it actually take to implement those stacks? What would it take to really get going with that level of service discovery? And typically for console etcd, you've got some sort of master, a concept of a master container, and you've got agents running in other containers. And then, you've got Registrator running on each one of your nodes, watching the local Docker socket. And then, you've got to put console template and confd actually in the same container as your Nginx or your HA proxy, your load balancer. So you're taking on a lot of complexity when you go to use one of these stacks. And if your application doesn't necessarily warrant that much complexity, it could be actually kind of a huge turnoff to service discovery in general. And you might not adopting, just the concept of service discovery in general. So we took a look around, like considering that sort of thing, we took a look around and saw what some of the other options are out there. And we found this project called Interlock. And it's this kind of little homegrown open source project from a fellow at Docker. It's not actually a Docker project. It's like kind of his own home thing, but it's actually being used in some of the Docker documentation. And it really kind of ties together a handful of these things. It's your service registry bridge, your config writer, and your reloader all in one. And it doesn't need to be bundled in with your load balancer. So you really wind up with only having one of these per service. So you have one interlock and one load balancer, per service you want to run. And I'm not going to say microservices, but there I just said it. So if you've got a bunch of different services in your cluster, this is one way of doing service discovery for them. So here's how Interlock actually works. And conceptually it's relatively simple. So if you've got you run a container, you pop a container and it lands on this node. Interlock is going to see that event coming off the Docker event stream, it's listening to the Docker event stream off the Docker Swarm management container. It then queries the Swarm for more information about the containers, including the one that was just created over here in 1. And then it goes ahead, writes that configuration into Nginx, as say one of the upstream servers. You've just created, you've got these other 2 apps as your other 3 as your upstream servers. Now you're adding 1 more. So now you've got 4 upstream servers written into your Nginx configuration. And then you just go ahead and you very much just do a reload of that container. And this is how Nginx likes to be reloaded in a Docker container, by doing a kill and sending it the HUP signal. So if you want to learn a bit more about interlock, it's just on GitHub right now in this fellow's, his user space in a repo. When I came to the project, there were a couple of things right away that there's actually a few things I noticed right away that it was missing. It didn't have support for overlay networks. That actually just merged like last week. The extension configuration templates, and when I say extension, I mean like the load balancers, Nginx or HA proxy. So those configuration templates were actually compiled into the interlock binary. These were, what? that was exactly my reaction too. What? So I said, okay, well, maybe we should take those out. And so I've got a pull request out there right now for extracting those from the binary, just turning them into text files, and making them example documentation. It also needs support for multiple services. So that's what this multi-interlock config support is. I've got a proof of concept commit out there that I'll be turning into a pull request pretty soon once this thing lands. So now I'm not trying to claim that, interlock is the solution. It's more like this is how I kind of view it. So when it comes to learning discovery, learning service discovery, I feel like, the crawl, you start crawling by using overlay networks and just like the DNS that's running on your clusters by default, now that you have overlay networks. Kind of the walking option is interlock. Conceptually, it's pretty simple, and you can make it go pretty quickly. There's not a lot of moving parts. You can just stand it up and get it going right away. And then if you really need like one of the heavyweights and you want to start running with this stuff, then adopt, etcd or console.
Hey, Everett, I had a question.
Shoot.
Can you go back to that slide where you had diagrams?
Yeah.
So in this diagram, how does interlock know to like rewrite the Nginx config? Like, is that sitting in a volume, or how does that work?
So it knows to rewrite it because it sees, like when you create this container,
right?
There's the Docker event stream.
Sure.
And it sees it sees both the create and the start events. And then when it sees that start event, then it knows that, oh, I need to find out more about this particular container, in all the containers. And it goes ahead and it writes, it's got the volume from this Nginx mounted into, its container. Yeah.
Oh, I see. Okay.
Yeah.
Yeah, and then it just restarts. That makes sense.
Yeah. So I don't make that super clear here. I just say interlock rewrites nginx.conf. No, it's, you know what it does now? It used to be a simple volume mount. It actually does a Docker copy now, I think is what it does. I think that changed recently. So now it actually just copies it, right? Rather than having to have that affinity between the two containers and necessarily live right beside each other. These could actually be very independent and live anywhere. And it just does a copy. It copies that file information. Say again? No, it works for HA proxy too. Yep.
I'll point out that that's what registering is doing, right? It's listening to Docker events and inferring all of the services from those.
That's right, yeah. So the question was, is that effectively what Registrator does as well? And essentially, yes. It's listening to the Docker event stream and writing things to, either etcd or console or like a handful of other things. Yeah. It's that what they termed a service registry bridge. I'm sure you could probably call it like a half dozen other things.
I don't.
What happens if the left node dies? Am I dead?
Yeah. So effectively, yes. At this point, you are, because it's going to take out your load balancer. It's going to take out your Nginx load balancer. Now, if you want to set yourself up, your Nginx itself in a highly available system, that's something that you'd have to configure and work out yourself. Yes. But if you lost your interlock container, that wouldn't be the end of the world. You wouldn't be dead in the water. You just wouldn't be seeing anything coming or going. You wouldn't, if app containers were being created or destroyed, they just wouldn't be seen, right?
Is there any? It has to be on the same node.
Nope.
No, right? So you just drew it that way, but master could have been on the other node and interlock on this one, right?
Yeah, just for convenience of not so many overlapping lines, basically. Oh, something behind you.
So typically in, sorry for the word, but in a microservice-oriented application, you have dozens of microservices or services. So isn't it a little bit overkill to have an Nginx for every single service?
Sure. I mean,
and if you go high availability, you have to have 2, 3 of them. So.
Yeah, I mean, it's however you want to roll your infra, right? There's a dozen ways to skin this cat. This is one of those ways. If you wanted to have just a single Nginx, then could you use interlock for that? Probably. Once the templates are externalized, they're much more, they're infinitely malleable at that point. So you could conceivably do that. I haven't done it, so I wouldn't say for sure.
Yeah, I think one thing to point out is that this is a pattern, but it's not necessarily the pattern, or we're not saying that this is like the right way to do something. There's many ways to solve a problem. This is one way.
Yep. Okay, so go through these really quickly. Just some of the different ways that we've seen Swarm being used. We use it heavily ourselves on my team, the developer experience team. We have customers use it. We have other people in Rackspace using it for different things. This is from Nick Silke on the Rackspace Cloud DNS team. They took a ChatOps Hubot off of Heroku and migrated it to Karina. And I mean, in itself, it wasn't like a huge, amazing technical feat or anything. It was literally a couple of containers. What was kind of remarkable about it was the amount of time it took. It took them less than an hour to do that. And that included migrating their Redis data. And this is a link to a blog post with a lot of great details on it and more silly GIFs or GIFs. Depends how you want to pronounce it. I won't go there, sorry. Okay, of course it's for running services or microservices, if you will. Sorry about the dark, low-res picture here. So we're actually very much in the place where we've got a collection of Docker nodes, and we're treating them individually. And we need to move them over into Karina cluster in order to eat our own dog food, basically. And this was the architecture that actually motivated me to start contributing to Interlock and enabling that for this architecture here that you really can't see at all. This was a whiteboard session I had with one of the guys on my team. This is really very cool, and I highly recommend checking it out. It can enable this really cool way of actually teaching people new things. So one of Carolyn on our team created this thing called How to Whale. And what it does is it allows you to, from your web browser, you go to How to Whale and you go to sign in. And it does OAuth with Karina. So if you have Karina credentials, you'll OAuth to Karina. then it'll spin up a cluster on your account. It'll spin up a Swarm cluster on your account and deploy a Jupyter server on it using a thing called Jupyter Hub. From that Jupyter server, you can run Jupyter notebooks. Now, if you're not familiar with Jupyter notebooks, and there's really no reason you should be, it's really kind of like interactive documentation in a sense. There's a bunch of different ways to term it, but you can interleave prose and executable anything, basically, Bash, Python, Go, anything that Jupyter has a kernel set up for, you can execute from this web page that's displaying this notebook for you. It's a really very cool system. So and the one that's kind of the default of how to whale is Docker. So you're running these Docker commands on this web page, and it's actually running containers on your cluster. So you've got this kind of crazy inception thing going on where, you're running containers and containers, not containers and containers, but you're running containers in your cluster, basically doing whatever it is Jupyter allows you to do. And if you think a couple steps ahead, this is the kind of thing you could enable for your own projects. If you wanted to just demonstrate your open source project, you'd say, just OAuth, and they can start creating, your open source project within their own cluster, within their own sandbox. And then there's, of course, you can run websites and whatever powers them on Karina as well. There's a great blog post here about running this site called Scoutapark on Karina. Goes into, it's fairly high level, and Scoutapark is this cool site where you can go and basically rate parks if you want to find out what's a good local park for you. I think there's quite a few Austin parks rated. And this was actually DevOpted by, or I should say, strategic advisor to this website was our very own Paul CZ here. And if there's time, we can stick around at the end and he can tell us a bit more about it. Okay, finally wrapping things up. First, I want to point out that at the end of this month is the OpenStack Summit. And we're going to be there. Of course, Rackspace is going to be there in droves, right? And we're also renting out Michelada's cafe across from the Austin Convention Center. And we're renting that out for 3 days for, all things Rackspace. Tuesday is the Karina Day. So, if you want to get a bit more information about Karina, I'm going to be doing this presentation here again with all of the feedback that everyone gave me, which I really appreciate. I've personally learned a lot up here right now. Taking that feedback and putting it back into this very presentation. So yeah, come on down if you like. It's a free event. You can sign up from that link there. And there's going to be talks from us, Google, and some of our customers too. So come get a meal and a drink or whatever. T-shirts, yay! So I'm going to make basically a standing offer that if you at any point ever want to come up to me I'm always at Docker Austin. If you want to come up to me and show me something you've deployed on Karina, I will give you this T-shirt. And it can be the most basic thing. If you want to do the, I guess I probably already hope one. Yeah, just run through any one of the tutorials, even if it's the getting started tutorial and it's just that WordPress. Then go ahead, show it to me, and I'll grab you one of these. You get this funky Borg cube on the back. Thank you so much for sticking around for this. Thanks for the pizza and the beer. Thanks to everyone. So this is the only thing you need to remember from the whole presentation, rack.to/swarm. That'll take you to this presentation right now. It's all online. This is going to be my ever-evolving presentation on effective swarm. As I continue to learn, I'm going to continue. Give me a shout out on Twitter about what you've learned or what you've deployed. That would be really cool. Okay, thank you so much, everyone. Cheers.